Why do deep-sea creatures evolve into giants? The bizarre and fascinating world below. Imagine plunging into the dark, cold depths of the ocean, where sunlight never reaches, and a different world exists. One full of creatures so bizarre, so alien, that they might as well be from another planet. But one question has fascinated scientists and explorers alike. Why do many of these deep-sea creatures grow to enormous sizes? From giant squids to humongous isopods, the deep ocean seems to breed giants. What causes these creatures to grow so big in such an extreme environment? The mystery of deep-sea gigantism. This phenomenon, known as deep-sea gigantism, refers to the tendency of deep-sea creatures to grow much larger than their shallow water counterparts. Think of the giant squid, which can reach lengths of up to 43 feet, or the Japanese spider crab, whose leg span can stretch over 12 feet. Even something as seemingly insignificant as an isopod, which resembles a roly-poly, grows to the size of a small dog at deep depths. But why does this happen? The answers aren't straightforward, but scientists have been piecing together clues for decades. To truly understand, we need to examine the deep ocean itself and its unique conditions. A world of darkness and pressure. The deep ocean is a place where few organisms can survive. It's cold, with temperatures just above freezing, and the pressure is immense, crushing anything that isn't built to withstand it. At these depths, there's no light at all. So how do organisms adapt to such an extreme environment? Interestingly, these harsh conditions may actually promote gigantism. One theory revolves around low temperatures. In the cold depths, chemical reactions slow down, and as a result, metabolic rates of creatures decrease. A lower metabolism may contribute to slower growth rates, but longer lifespans, allowing these creatures to eventually reach gigantic proportions. Imagine living 100 or even 200 years, slowly growing over the decades into a massive creature. Then there's the immense pressure. At depths of over 1,000 meters, the pressure is more than 100 times what we experience at sea level. This pressure affects the structural build of creatures, and evolution might favor larger, sturdier bodies that can handle the environment more effectively. Essentially, being bigger makes it easier to survive in this brutal environment. Survival of the fittest, or largest. The food chain at these depths is also very different from what we see closer to the surface. Nutrients are scarce in the deep ocean. There's no sunlight to fuel photosynthesis, so most food arrives as marine snow, a slow drift of dead organisms and organic matter sinking from the upper layers. Sometimes a whale carcass may descend to the bottom, providing a feast for years, but meals like this are rare. This scarcity of food has led to another potential explanation for gigantism. Larger creatures can store more energy and travel further in search of food. A giant squid, for example, might have an advantage in catching prey due to its enormous tentacles and powerful body. It also might be better equipped to survive long periods of time without eating, making it more resilient in this extreme environment. Take the colossal squid. Even bigger than the more famous giant squid. It has evolved not only size, but also specialized body structures like huge eyes, the largest in the animal kingdom. These massive eyes allow it to detect prey even in the pitch-black darkness of the deep sea. The oxygen hypothesis. One of the most intriguing theories for deep-sea gigantism is related to oxygen availability. As you go deeper in the ocean, the oxygen levels drop. To survive, animals in these environments have to become more efficient in using the limited oxygen available. Larger body sizes may actually help some species to circulate and retain oxygen more effectively. This is known as the oxygen diffusion hypothesis, a concept that argues that bigger bodies allow for more efficient oxygen transport in low oxygen environments. The giant tube worms that thrive near hydrothermal vents are a good example. These creatures grow to lengths of over 8 feet, even though they live in one of the most hostile environments on Earth. By being larger, they can better absorb the chemicals spewing from these vents and convert them into energy. Predators and prey. In the deep ocean, the dynamics of predator and prey are drastically different from what we see near the surface. Down here, some creatures, like the gulper eel, have evolved enormous mouths relative to their body size, allowing them to gulp down prey larger than themselves. Being bigger also makes it easier to capture whatever unfortunate creature happens to swim by. In this world of darkness, bioluminescence is another important tool. Some deep-sea giants, like the anglerfish, use light to lure in prey. The anglerfish might not be as large as a giant squid, but its ability to use its bioluminescent lure in the pitch-black environment of the deep sea is a testament to how evolution has shaped creatures in different ways. The legacy of the deep sea gigantism may also be a relic of the past. Many researchers believe that the conditions of the ancient Earth, particularly during the Paleozoic era, were more conducive to gigantism. Back then, oxygen levels were higher, and the deep ocean wasn't as isolated from surface waters. As sea levels dropped and the Earth's environment changed, these giants retreated to the deep, where they found refuge. Now, in the isolated and stable environment of the deep ocean, these creatures have continued to thrive. The deep sea still holds many mysteries. The deep sea is one of the least explored places on Earth, and we've barely scratched the surface of its mysteries. Gigantism is just one of the many strange evolutionary adaptations found in the dark depths of our oceans. As we continue to explore these realms, who knows what new giants we might discover, or what bizarre new adaptations we'll encounter. So, next time you think about the ocean, remember that far below the surface, an entire world of gigantic, alien-like creatures is waiting to be discovered, where size really does matter. What do you think lies in the unexplored depths? Could there be creatures even larger than what we've already found? Leave your thoughts in the comments below, and don't forget to subscribe for more deep-dive explorations into the world's greatest mysteries. Don't forget to like, share, and subscribe for more cool stories like this. Let us know what you'd like to see next in the comments. Thanks for being awesome.